Do you guys have in front of you what I have up here on the board right now? All right. I'm going to grab my name list here so I can try and practice. Hopefully by the end of the day I have everyone's name memorized, and we'll see how it goes. So, guys, section 1.1, simple equations. Is that what it says for you guys? Okay. Real quickly, word equations. You're going to hear it a lot this year. You've heard it before. I guarantee you've heard it before. What's your best definition of an equation? Yeah, show of hands on this. What's your best definition of an equation? Maybe I should rephrase it. What sign do you always think about when you're dealing with equations? Do you have an idea back there, Max?
Solution.
There's a solution to an equation. I totally agree with that. There's going to be a solution to an equation. What sign's always going to be in an equation? Yeah. There's going to be an equal sign there. Jasmine, is that what you were going to say? There has to be an equal sign, okay? So, guys, when I start asking questions like this, kind of to prompt you a little bit or cue you this year, do you guys see the vocab stuff I've kind of put in the middle of the page down there? Is equation one of those words? It is. Kind of look through there sometimes because I'll start asking questions and you're like, oh, it's a statement where two expressions are what? Equal. Okay, so that stuff will be down there. You guys have dealt with equations before. Give me a show of hands. How many have dealt with equations before? Give me an example of an equation you maybe solved before. What's an example of an equation maybe you've looked at solving before? Riley, what do you think? No, I've got that wrong. Braden, right? Sorry, my mistake.
2 plus 2 equals 4.
2 plus 2 equals 4. The left side, 2 plus 2, does that equal 4? Yeah, excellent. That would be a numerical equation. You guys ever dealt with what we call variable equations before? I'm sure you have. What the heck's a variable? You look like a puts to me, is that right? Go with it, Kendall.
Like the letter.
Yeah, it's a letter. It's a letter that we use to represent a number, okay? You guys have all seen stuff like this. I'll make this very simple because this is really going to be the gist of today. We're going to fly through this. You don't need to write this part down. Very quickly, what's the solution to that? 2. 2 times 2 would be 4, right? What's the variable in that equation? X. What's the solution in that equation? What value for x would make that true? 2. Okay, right? Solution would be 2. Okay, expression on the left, 2x. Is that expression on the left variable expression or numerical? Variable, has letter. How about the expression on the right? Is that numerical or is that a variable expression? Numerical, it's just a number, right? So when I start throwing all these terms out here, are you with me right now? That's my first question. Give me some sort of a sign that you're alive right now. Yes? Okay, all right. Well, let's rock and roll here, guys. Today what we want to start looking at are simple equations. I guarantee we've probably seen this before, but let's kind of get comfortable with this again. Volunteer to read my essential question. What are we trying to accomplish today? You want it, girls? No, you're stretching. All right. Who wants to read that essential question for me? Anybody want it? Oh, don't be shy. Come on. Go, Kayla.
How can you use simple equations to solve real-life problems?
Okay, that's what we're after today. How do you use simple equations to solve real-life problems? I've always tried to make a connection as to how this stuff applies, okay? So goals for the day right here, guys. Goals for the day. The first goal we're looking at is solving linear equations using addition and subtraction. We're also going to solve linear equations using multiplication and division. And we're going to look at linear equations to solve real-life problems. I'm going to go ahead and I'm going to put a word up here, guys. I'm going to put this word up here. This phrase actually is going to be said using inverses. Now I don't doubt that you already know how to do some of the stuff that we're going to do. I don't doubt that for one bit. But I think it's important that we talk correctly in here and use the proper vocabulary when we do stuff. So when I say we're going to use addition, subtraction, we're going to use multiplication, division, we're going to look at inverses right here. What the heck am I talking about using inverses? Any idea what the word inverse means? Any idea what the word inverse might mean? Any idea?
Operations that undo each other.
Operations that undo each other. So when I'm talking about undoing stuff right here, we're going to say, what's the inverse of addition? You're going to simply tell me subtraction. What's the inverse of subtraction? Inverse of multiplication? Inverse of division. I have a question then. What if I throw a fraction out in front? How do you get rid of fractions out in front? You remember how to do that? I'm going to use some really big words, and you're going to look at me like, oh, I'm not sure. Jadlyn, have an idea? Multiply by the what? Reciprocal. What the heck's a reciprocal? Remember what a reciprocal is, Jadlyn? Fraction upside down. Basically, for me, when I'm out on the weekends doing my WWE moves, my finishing move is the reciprocal. It's actually the opposite reciprocal, but it's true. It's true. I come out as a square root of P, my big cave, my mass. I set them up with a fine parabola. You don't believe me, do you? You don't believe me, do you? Okay, well, anyway. Yeah, multiply by the reciprocal. What she's getting at here is this. If I had something like this, and we'll look at examples. If I had something like 3/2 x right here, if I wanted to get rid of that 3/2 out in front so as to solve for x or get that alone, say it again, Jadlyn. What would you do to that to get rid of the 3/2? Multiply by the, okay. There's a ton of phrases I'm throwing at you right now, and I know I'm going 100 miles an hour, and some of you are probably like, oh boy, better keep up. That's fine. Let's rock and roll here. Let's get through this vocab here. Everything in the goals right here is going to come back to using what? Using inverses. This is all fancy stuff for saying using inverses, okay? All right, I want to run through some vocabulary here quickly so that we have this down. This is going to go quickly. Conjecture. I think the thing you need to underline in conjecture is that it's called a what? It's an unproven statement, okay? Obviously, there's two people running for the White House right now, right? We all know who's running for the White House right now. Okay? I'm going to make a statement. Hillary Clinton will win the nomination. Polls say that she's in the lead right now, but have I proven that she's going to win the election yet? So it's unproven right now, isn't it? So would that be a conjecture if it's unproven right now? Okay, so conjecture, something that you cannot prove. Seems like it might be right, but you haven't proven it yet. Does that make sense to everybody? Okay. Now what's the difference between conjecture and rule and theorem here, guys? What's the one word in here that would change from conjecture's definition to a rule's definition? Proven. Okay. Something you can prove. All right. Give me something. Give me a statement of something that's been proved. I'll say one right now. The Denver Broncos are the best team in the NFL right now. Why can I say that right now? Because they are the last team to win what? The Super Bowl, right? Max, you were going to come up with one. What were you going to say? Something that's proven. 2 plus 2 is 4. We can prove that, can't we? That's a proven statement. 2 plus 2 equals 4. In math, we get kind of goofy. We like to be kind of, I don't know, when I was in school, I was president of the math club. Insert laugh now, okay? You know what they used to call me when I was president of the math club in high school? I was called president of the nerd herd, okay? And I liked that. I embraced it. I thought it was great, okay? Instead of using rule in mathematics, what word are they going to use? Theorem. Theorem is the same as a what? You guys have heard of Pythagorean theorem before, right? That's a rule. It's a rule about triangles, right? Theorem just means it's a rule. You can prove stuff. Okay, let's run through this. We've already talked about an equation. It's a statement where two expressions are equal. You guys already gave me an example. I'll give you another one. How about 3x equals, I don't know. How about 36? Do I have an expression on the left of the equal sign? I do, don't I? In 3x. Do I have an expression on the right? I do, don't I? Okay. Two expressions that are equal to each other. Okay. Linear equation. You're going to hear a lot about this down the road. It's the equation of the form ax plus b equals what, guys? What's it say? Ax plus z is going to equal what? 0. It says A and B are simply what? A and B are simply going to be what? As an example, you might have something like this. You might have, like, I don't know, negative 4x plus 12 equals 0. That's going to be called linear form. And when I start talking linear form as an example right there, I said A and B are going to be values. So in that AX plus B form, what if I would say, what's the A value in that expression that I wrote? What would you say the value of A is in that right there? Negative 4. What's the B value in that? 12, positive 12, right? Okay, so just understand A and B are some value. Okay, then a solution is going to be any number that would make that statement true. So can you guys look at this linear equation right here and say, all right, what value could I plug in for x to make that statement true? What would plug in there for x on the left to make that equal 0 on the right? Anybody have a thought? Braden, what do you think, kiddo? 3. Check it out. What is negative 4 times 3, guys? Negative 12. Negative 12 plus 12 more? 0. Yeah, 0. Number of days of vacation you have left right now. Okay? Solution is simply x equals 3. Okay? Inverse operations we've talked about already. Stuff that does the opposite, or phrase that I'm looking for, undo stuff. We already talked about that. And then the last thing, equivalent equations. Equations that have the same what? Here's an equation. I'll write x plus 3 equals 9. And down here I will write 2x equals 12. You tell me, what are the solutions to both of those equations very quickly? 6. Do both of those equations possess the same solution? They're both 6, right? My question then is this, are those equations equivalent? Is the top equation the same as the bottom equation? The answer is actually going to be yes, because the solution is the same, okay? These are going to be equivalent equations because when you get the same answer for either equation, in this case right here, for both of these, x would equal 6. So voila, you have it, okay? If the answer is the same for 2 different equations, then those equations are called equivalent equations. This isn't so bad, is it? Makes sense so far? So far, so good? Anybody ready to get up and run out the door yet? You guys are really good liars. I love it. Okay? All right. Let's get into the nuts and bolts of this stuff. Let's figure out what we need to know today. Again, the essential question is, how do we use simple equations to solve real-life problems? Okay? Excuse me. What's this word mean right here that I just underlined in red? What's the word, first of all? Yeah.
Prerequisite.
You got it, prerequisite. Anybody know, I would say to be able to take calculus, college prep math is a prerequisite. What's that word prerequisite mean? Anybody have an idea? How many have heard of the word prerequisite? Okay. How many of you guys have dreams of going to college after high school? Anybody have any idea what they may want to do yet? Have a thought? What do you want to do, think? Be a physical therapist. Okay. Do you think that getting through physical therapy, that there's probably an order to the classes you would have to take? You just can't skip around, take this, and then take this, and then come back and take something easier? Or do you think they kind of do them in a sequential order? Probably do them in order, right? Prerequisite means it's something you need to know before you can even solve the problem, okay? So, what do we need to know for this lesson? Here's a statement that's going to be very important. How about a volunteer to read this statement for me? Volunteer to read that statement right here. I need to start learning names. All right, Kayla, you've been assigned as the designated reader in our class, it sounds like. I love it. Go for it, kiddo.
The sum of all 4 angles in any 4-sided figure adds up to 360 degrees.
How many of you guys have heard of that before? How many knew that already? 4-sided figure, sum of the angles on the inside is 360 degrees. You've heard that before, Haley? Okay. Yeah, let's do this. I'll draw a four-sided figure. You guys can do the same thing too. I'll try this. I'll try and draw a nice four-sided figure. Anything with four sides. There it is. Very nice. Very nice. Okay. I'm going to call this angle right up here. How about this? 92 degrees. I'm going to call this, how about 87 degrees? And I think I'll call this angle up here maybe 64 degrees. Now here's the deal. You guys are trained to think using algebra all the time. You just don't know it. Okay? I have three angles right up there in a four-sided figure. There should be angle measures for all four of them. Is there enough information up there to know all four of those angles? Okay. Somebody kind of give me a synopsis or some kind of a summary as to how you would find that last angle. Don't tell me what the answer is, just tell me what your process would be in order to figure out that last angle up there. If I said, hey, here's the problem, solve for that angle. I want to hear it in words. What would you do? Run with it, Max. What have you got, kiddo?
So I would add them all up and then subtract by how many possible they are.
Okay. What are you going to subtract from? What value?
360.
So you're saying, you know what? All four of these angles have to add up to 360, right? So this is an excellent lead-in. I guarantee you've seen stuff right here. So you're telling me add 87, 92, and 64. Is that correct? Okay. I'm not very good at math, but somebody check me on this. Is that 243? Who's got a calculator handy? Run those three numbers for me. See if that adds up to 243. And if your phone is your calculator, that's fine. I'm fine with that. 87, 92, 243, is that right? Okay, so I have this unknown angle down here, which I called what? What do I call this unknown down here? What variable did I use? X. You're going to ask to write equations. X plus this angle, 243. Where'd that 243 just come from? Where'd that 243 just come from? Yeah. Those three angles that we knew already. That has to sum up to what value, kiddos? 360. Written an equation right there. Max, you said take 360 and minus that number 243, right? If I wanted to get x alone right here, 2x, you're adding 243, but you said subtract 243, right? How is subtraction related to addition right here, the way the equation is written? We would call subtraction an inverse of this addition. If I want to undo addition of that 243, you would have to do what to both sides, kids? Okay, and you've heard this before. I know you've heard this before, so I'm not going to take the time to tell you that you've seen this. This is a prerequisite to be in this course. You know that subtracting 243 is going to get that. I'm not very good at subtracting, but I believe the answer here should be how many degrees? Shout it out, anybody. 117, yeah, you bet. Okay, so there's a perfect application for y. Well, I don't know this angle, so I'm going to call it x as my unknown. We're going to say x plus these other three angles, sum, 243. That sum has to be, by our prerequisite, 360 degrees. You've written an equation, you've solved it. Okay, that's the whole point to today. Okay, so my question is this. Are you okay with what's going on here, first page? Are we okay so far? Yay, nay? Give me some sort of sign to your life right now. Are we okay with this? Okay? All right. You guys sit there like this, and I'm getting ready to call 911. Problem is, I don't know the number. Okay? All right? So just give me that sign to your life, and we'll be good, okay? I love it. Let's roll. Page 2. Okay. I'm going to get you a core concept. I want you guys to get some rules written in here. Okay? you'll see stuff like this in your book, but I think you'll be okay with it. And keep in mind, where's your book really at right now? It's in the Chromebook, and I'll show you how to navigate that here in a little bit. But you guys, when you start getting the assignments and stuff, if you want a book to take home, let me know. Okay, is there anybody that wants a book along with the Chromebook? Okay, if you're like me, I must be old school. I must find. Okay, addition property of equality. It says the following. Let's just suppose that we're going to let A equal B. So right in here, if I let A equal B, what's the addition property of equality? Right? So right in here, we're going to let A equal B. So here's the deal, guys. If these two are equal to each other, you have the same amount on the left as you do on the right. So if I add something to the left, what amount do you have to add to the right to still keep this balanced or equal? Same thing. So the addition property of equality says that if you add something to the left side, let's say A plus C, then that would have to equal what on the right side? Remember, we started, A and B are equal. To A we added C. So to keep that balance still, B was over here, which was the same as A. I know I'm throwing a lot of letters out here. It's not an English class. But what would you have to add over here on the right side to keep balance? So A plus C has to equal what? B plus C. Excellent. Okay? So that's the addition property of equality. If you add one amount to one side, you have to add the same amount to the other side to keep it balanced. So if I start talking about subtraction property of equality and say, yeah, A and B, they're the same thing, what do you think the subtraction property of equality is going to look like in terms of variables? We start out with the same amounts, and we want to subtract from the same amounts to still keep them balanced. So what's the rule going to look like? Anybody have a thought? Run with it, Braden.
A minus C equals B minus C.
Yep. If I subtract C from the left side, I have to subtract the same amount from the right side to keep that equal. That's simply what the subtraction property of equality says. Okay? All right. Substitution property of equality. This is a goofy one. All right? This is a goofy one. We're going to let A equal B, and then we're going to let B equal C. So we're saying, hey, you know what? A is equal to B, and B is also equal to C. So what other statement could you come up with there then, knowing that information? Letter A is equal to B, but B is also equal to C. Gross, what do you think? A is equal to C. They're all the same. If B is equal to A right here, guys, and B is also equal to C right here, what's that imply about A and C then in terms of their value? They must be the same. Yep. So we could substitute. We could say, you know what? If A is equal to B and B is equal to C, we could substitute A in for B right here and say A is equal to C. All right. And again, these are kind of rules that I just want you to know what terms come with them. I think you've got the idea. Multiplication property of equality. It says that if I have A equal to B again, okay? So you have an A equal to a B right here. These two expressions are exactly the same. We're gonna, what's the property's name up there again that we're on? Multiplication property of equality. So we're gonna do what operation to both sides to keep them the same? Multiply. But we have to multiply both sides by the same thing. Anybody have a guess what this rule looks like then? Shout it out to me, anybody.
A times C equals B times C.
Awesome. AC is equal to BC. Understand that when there's two letters just next to each other like that, the operation that's always implied will be multiplication. AC, just like that, means A times C. Are we cool with that? Cool with that? Okay, and then I won't waste your time here. Let's get the next one. This next one says A equals B again. Division property of equality. Starting with the same things. So we would have to divide both sides by the same thing to keep it equal. So anybody have a guess what this is going to look like? A divided by what? C has to equal B divided by C. You guys rock. Nice job. Nice job. So let's get rolling here. Any questions so far? Any questions so far? Do you at least have everything written down to this point? Got me or not? I mean, yes or no in math language. Yay? All right, let's roll, kiddos. Question or just stretch? Okay. Guys, this is where things get kind of interesting for us, and I think we know how to do this. Talk to me about process. Not so much about what the answer is. Talk to me about process. Guys, we're solving equations by adding or subtracting. Okay? We're using inverse operations. All right, so here we go. Okay, this says the variable d minus 1/4 equals negative 1/2 in your notes. Okay? Our goal is to try and isolate your variable. Get that alone. Find a solution. Solve for it. There's so many different ways you could term that. Okay? What are you doing to d on the left side right now? It says d. What are you actually doing to the d right now? Subtracting how much? 1/4. Suppose I wanted to get d alone. I would have to undo subtraction of 1/4. So to undo subtraction, you're going to have to what? Add. That would be like an inverse operation. Do the opposite. So what are you going to do to both sides here to get d alone? Add a quarter. You know this. I don't think there's a single person in here that doesn't know this already. Ooh. Ooh. All right, now this is where I need help, though. What's a negative 1/4 and a positive 1/4 really equal out to be? So we say the negative 1/4 and the positive 1/4, the subtraction of 1/4, the addition of 1/4 undo each other. They're inverses of each other. In other words, what's the word I'm looking for? They cancel each other. Okay? This is gone, leaving you with which variable on the left? Solving an equation means to get your variable isolated. D is all alone on the left. All right, trick time. What's negative 1/2 plus a quarter? Adding, subtracting fractions. Anybody know? Raise your hand if fractions are your favorite thing in the world. I thought so. Raise your hand if fractions are maybe your most hated thing in the world. Okay? I agree with you. I'm a decimal guy. I like decimals. In order to add fractions, you have to have a common, what's the word? Denominator. I got a 4 here. If I wanted to make this a 4 right here, what would you have to multiply by? 2. Isn't this the same as negative 2/4 up top there? Plus a quarter? What's negative 2/4 plus 1/4 going to get you? Right here. What was it again? 1/4, right? Negative 1/4. Okay? L, right? Got it right, fine. I'm going to give myself a pat on the back. Is that okay? Okay, negative 1/4. You got this. You guys try and do this one on your own quickly. Part B. Raise your hand when you've got a solution. Check with a neighbor first. See if you agree. Check with a neighbor first. See if you agree. Again, the calculator is, if you need a calculator and it's in your phone, I'm okay with it if you're using that, okay? Raise your hand when you've got a solution. Make sure you agree with somebody. I'll go when I have 5 hands in the air. 3, 4, 5. Keegan, what'd you get, bud?
4.4.
4.4. How many are going 4.4 right now? Okay, that's probably going to be your grade point average by the end of high school, right? 4.4 on a 4.0 scale. That's awesome. Way to go. How'd you get that? That's my main concern.
You subtract 4.8.
You're the man. How many agree with subtract 4.8? Okay, why were you subtracting? What the heck? It says add.
You have to cancel it.
But it gives you the answer. What are you really doing when you subtract, though? This whole concept is about using, undoing stuff. What's that word? Excellent. Yes, we've got to subtract. We've got to undo this. Minus 4.8. Subtract. You said 4.4, kiddo?
Yeah.
How many had 4.4? Are we okay with this right now? We're undoing operations. That's all you're doing. One step undo. Okay? Let's try another one here. Guys, when I write this fraction, m over 5, what operation is really occurring here? Whoops, I wanted to go the other way. That's not good. There we go. Whoa, whoa, whoa. This is really what operation over here? Division. So if I want to get rid of that division, what are you going to do? Multiply, right? What are you going to do to both sides? Multiply by what? Multiply by how much? Okay, this is where things get kind of goofy, and this is where I want to make sure that we are all on the same page with stuff. M over 5 is the same as m divided by 5. Would you agree with that? Would you agree with that? I think it's a good idea to multiply both sides by 5. If you ever have a fraction anywhere, I really believe you should use fractions in your inverse operation. So for instance, do we have kind of a fraction form right here? We do. So I'm going to call this 5. 5 in fraction form is really the same as 5 over what? 1. And I'm going to do the same thing over here. And let me show you why I'm doing this. What are the 5s really going to do to each other? One up top, one on the bottom. Cancel, aren't they? And then m over 1 is just the same as m divided by 1. Anything divided by 1 is going to be that thing, right? So we're going to end up with m equals, help me out guys, what's negative 4 times 5 here? How much? Negative 20. Okay. Okay, one thing I've got to tell you. As a kid, 5 years old, going to NASCAR races every single year from age 5 to now, these things don't work the best sometimes. So you got to shout it out to me, okay? You got to shout it out to me. Negative 20. Okay, I think we're okay with that one. Where I get concerned is something like this. Okay? In fact, you guys take a minute and talk with a neighbor and see what you think you might get as a solution here. This is concerning to me. This is not so easy. Even though it's a one-step problem, this isn't so easy. Go ahead and solve that and tell me what you think you get. Oh. Have an answer? You guys have an answer at all yet? You guys have an answer? Not this one? Listen, it's okay to get stuff wrong in here because you know what? I'm going to stand up in front of this room and make 100 mistakes, probably 128 mistakes this year, okay? So it's okay to make mistakes, but talk with someone right now. See what you've got. You got it, Jadalyn? Oh, did you start there? Sound like I'm sorry. You're not going to turn me in, are you? Okay. Braden, you got it, buddy? Okay, so I really like what you're doing. You're dividing by 3. All right, I'm hearing some good conversation. Anybody want to argue an answer right now? Anybody want to stick up and say, hey, I know I'm right because this is tricky. This is tricky. I have an idea. Let's just not even work with fractions all year this long. Life will be good, right? Yeah. I wish it was that way. I really do. I wish I could. But we're going to fix this, all right? Who's got an answer they're confident in right now? What's that, Braden?
I have 2 answers.
2 answers? Okay. Jadlyn, are you confident? Jadlyn, what do you have for a solution?
P is equal to -2
All right, I'm going to jot this down here. How many agree -2/9? How many have something different than -2/9? All right, Braden, what's your solution here?
3 2/3.
Okay, positive 3 2/3 or negative?
Positive.
3 2/3, you say? Can I ask a question? Did anybody have -2?
If that's the
-2 is what you've got?
that's right.
All right, these are the types of things right here where I think learning, how do I want to say this? This is where I think learning for kids is best, when there's disagreement between answers. Because people have to defend an answer they get. And not all the time mathematically are we going to agree on answers, okay? There's going to be times where maybe Kayla and Wagner are going to argue about an answer, and all of a sudden one of them's like, oh, yep, you're right, I understand now. I think that those are some of the most important learning moments in the classroom for math, when you guys have discussions about how to do something. And I strongly, strongly, strongly encourage you this year to get with somebody as you're going through problems, to talk about things that maybe you're missing or not getting or understanding. But the one thing I always urge you to do is check with neighbors around you when you do get solutions. If you get stuck, ask a neighbor, okay? Ask me. Ask mom and dad. Mom and dad might tell you, kidding me? I don't know. All right, but that's fine. At least you're asking. Seek out some other solutions that people have to offer. You guys want me to circle the correct answer up here? Okay, first of all, where are my -2/9 people at? Hold them high so I can see. Okay, here's the deal. If this would have just been something like, you don't need to write down what I'm about to write. Down. Okay? Naughty. All right, let's see. If I would have written down something like this, 3p is equal to 12, very easily, what's the answer to this? It's 4, right? Because you take 12 and divide it by what? 3. Let me ask a question here. Over here we said undoing division is the same as multiplying by the reciprocal, right? Well, how about this over here? If undoing division is the same as multiplying by the reciprocal, couldn't that be true for multiplication also? In other words, times this by what? What's the reciprocal of 3? 1. What is the 3 times 1 still first, guys? Still 3p, right? And then divide by what now? 3, right? You agree with this? Do you agree with this? Do you agree with this? What's 12 times 1 up top? Divided by 3 now? So you're saying that if I divide by a certain number, that's also the same as multiplying by the what? So what I'm saying to you is this, and math teachers, I'm going to guess that no math teacher has told you this when you start talking about this concept. If you need to undo multiplication or division, you can always undo them with a reciprocal, no matter what. Multiplication and division can both be done, or I should say undone, with what's the word again? Reciprocals. That word's a pretty powerful word in math, in this math world is what I meant to say. Okay? So here's the deal. I could divide by 3, but I could also multiply this by the, what's the word again? Which is 1/3, right? Oh boy. When you're multiplying fractions, multiply numerators with numerators and denominators with denominators. Make sense of this. What's -2 times 1? -2, right? Right there. What's the 3 times the 3 right here? 9. Does it work out? Let me give you an example of why this is important. -2/9 is correct. Let me zoom down here, go to a new page. I want to write this up here. 5 halves x equals 40. Okay? This is where things with fractions get kind of goofy. You have that fractional coefficient, 5 halves out in front. How are you going to get rid of that again? Multiply by the reciprocal. So what are you going to multiply both sides by? 2 over what? 2 up top, 2 on the bottom are gone. 5s are gone. Multiply this by 2 over 5. This really becomes 40 times what? 2, which is 80, and then 80 divides 5. It's a sweet birthday. 16, okay? Okay. So understand that if you ever have multiplication or division going on, you can undo those with, what's the word? Reciprocals. Okay, very good. Let's get back to this right here. Did you guys do part C also? What do you guys have for part C? Anybody have part C figured out? Run with it, Jade. R is equal to 30. What did you do to both sides? Divide by 2.5. You bet. Or I could have multiplied by the reciprocal. 1 over 2.5. Doesn't matter. And R would equal 30. Excellent work, kids. All right. So let's model some of this stuff up here. Zoom up again. Can you guys in the back read that okay? Obviously you have it in front of it, but do you know where we're at on the paper? Okay. All right, so I'm on example 3 here, kids. It says you clean a community park for 6.5 hours. It says you earn $42.25. Right? Oh boy, this is the thing, guys. I know you can solve this, but the hardest part in math is, instead of solving a problem, the hardest part in math is actually setting up a word problem, isn't it? How many of you guys know you struggle with setting word problems up? We're going to work on that this year, okay? I knew I kept these books up here for a reason, okay? Thank you. This was like me in basketball when I played. I used to sitting on the bench a lot, okay? Now I just coach it, and I'm used to that, sitting on the bench, coaching it. How much money are you earning per hour? What's it say? How much money are you earning per hour? Shout it out for me. It says you earn how much per hour? Or no. I'm sorry. I read the question wrong. How long are you cleaning for? 6.5 hours. Okay, they're going to pay you a certain amount of money for the number of hours you work, aren't they? Wouldn't you take the amount of money times the number of hours you clean to make your total amount of money here? Would you agree with that? How many immediately know to solve this problem you would simply divide? Is that what you would do? You would just divide? So I don't want you to lose sight this year of what we're talking about. Everything is inverse operations. So right over here, Braden says, in order for me to solve this problem, you have to do what? What's the operation? Divide. Divide is an inverse of what? Okay. You know that you have to divide to solve that, right? And in order to solve that, that division had to undo multiplication, didn't it? Division has to undo multiplication. So I think if you know how to solve it, write the equation in an inverse way. And this is how it would work. The question says, how much are you earning per hour, doesn't it? Okay. Well, how long do you work for, guys? 6.5 hours. And we don't know how many, or what rate we're making money, how much money per hour we're earning. So I'm going to say 6.5 times the amount of money X we make has to equal your total amount of how much here, guys? 42 point what? 42 and a quarter. Okay, 42 and a quarter. The way I've set this up, does it look like you take 42.25 and divide it by 6.5? It does, doesn't it? If you know how to solve a problem, then to write it, you write it in an inverse way of solving the problem. What's the solution here? How much are you earning per hour? 7? Is it 7? 650? Take 42, I'm sorry. Take 42.25 and divide by 6.5 for me. Tell me what you've got. Braden, what'd you get? 6.5. So monetarily, what's that mean? $6 and what?
50 cents.
$6.50 an hour. You're not even making minimum wage. So what I would tell you is don't clean that part. You're not even making minimum wage. Okay. All right. Guys, I'm going to stop there. There's an example 4, I believe, on the last page. Is that right? Okay, let me stop this here. Give me a second. What I want to show you is this today, guys.